Thank you very much. And hopefully, since we're a small group, please feel free to ask questions if there's anything you want to know more about. I'm very happy to go off script. We'll see what happens. So to begin with, I'm going to be talking about paper and paper making and fiber and water and all sorts of delightful things like that. Let's see. Maybe I can remember how to work a PowerPoint. Next one. There we go. All right. Before we had paper, there was pre-paper. And what we see here are examples of some other materials that people used for communication prior to the development of paper. All of these are items that we have in the museum collection. And in fact, they're all on exhibit right now. So if you want to see them in person, I highly recommend it. The museum is located in the Renewable Bioproducts Institute, which is in the Paper Tricentennial Building, which, like, I don't know what any of those things are. That's totally fine. We're located at the corner of 10th and Hemphill, directly across the street from Sublime Donuts. So where Sublime is, stand at the door, turn and look at the big old building behind it. That's where we are. It's free and open to the public. We're open from 9 to 5, Monday through Friday, and we're closed during campus holidays. So with our pre-paper items, the oldest one is cuneiform that you can see here on the left-hand side. Cuneiform is a clay tablet. It's very durable. It's going to last a long, long time. The downsides to clay tablets is they are incredibly bulky. If you need to have a whole lot of information, you need a whole lot of tablets. You can't reuse them. They drop or they break very easily when dropped. So some disadvantages to this material. Durability, yay. Everything else, pretty low. If we were going to give it a star ranking, I'd give it like a 2. Papyrus. That is another material that's been around for a really, really long time. It's been in use for about 4,000 years, so it's got some longevity to it. It is thin, it is durable, it is flexible. You can do a lot of things with papyrus. Downsides of papyrus. It must be made from the papyrus plant, which only grows naturally in one portion of the world. So not really good for moving around to a lot of different spaces. Another problem with papyrus is that it breaks very easily. It tears once the fiber material has dried. And so again, it's not a super stable material. So papyrus, I'm going to give that about a 2 as well. Parchment over there on the upper right-hand corner is animal hide or skin. And it's usually from sheep or goats or calves. And if you look at it and don't get to touch it, it does look an awful lot like paper. It's about the same thickness. It's very flexible. You can write on it. You can print on it. There are a lot of great benefits to it. It can last a long time. This particular piece you're looking at is over 1,000 years old. So it's got some durability. So a lot of big check marks there. Big problem with papyrus, with parchment is it is hard to get. Like, but it's sheep, it's cows. Yeah, if you want to write a book using parchment pages, do you know how many cows or sheep you're going to need, how many hides you're going to have in order to have enough pages? So for example, the Gutenberg Bible, which is a good example because we know how much material was used for it, required 700 sheep or cow hides to produce one copy of the Gutenberg Bible. Now, if you're printing books, you're not stopping at one copy. So exponentially, sheep, parchment is not necessarily the most cost-efficient material to have. So I'm going to give, parchment and my completely arbitrary made-up system of rankings, I'm going to give it a 4. Leaf manuscripts down here on the bottom. Always a fan of a bad joke whenever possible, so I'm going to have one here. You've heard of loose leaf paper. This is a loose leaf manuscript. It is literally made out of leaves. This is a writing material that was used in parts of Southeast Asia for hundreds and hundreds of years. The leaf from select palm trees would be harvested, it would be flattened, cut into a rectangular shape, polished smooth, and then using a stylus, the message would be inscribed into the leaf, and then soot would be brushed over it, allowing your writing to show. So very cool. You have a big stack of them, you trip and fall, and now you have loose leaves everywhere. So it's a very easy to acquire material, check. It's tricky to write on, and then because it's a leaf and it is trying to decompose, it is not the best material for long-lasting preservation of information. So I'm going to give this one about a 3. That being said, all of these were meeting the needs of the communities that developed them. So why do we end up with paper? So paper was invented over 2,000 years ago, and it's one of the 4 great inventions from China. Gunpowder, paper, printing, and the compass are considered these 4 great contributions. So Tai Lun is credited with the invention of paper in the year 105 AD, although we have archaeological evidence that shows that paper had been around for about 300 years prior to that. Here's a statue of what Tai Lun is presumed to have looked like. Essentially, the tools and the processes for paper making have remained the same for about 2,000 years. And our first paper making material was hemp from ropes. All right, so again, we're looking at a 2,000-year plus history. The first thing you have to do in order to make paper, first of all, have any of you made paper before?
I did.
Excellent, and you have, wonderful, and you have, great. So you're going to have to, is what it boils down to. So the first thing you have to do is you have to gather your fibers, which can take place in a whole bunch of different ways. So I have a random assortment of different fibers that can be used. This is what puts paper making over the top. It is not one specific plant material that you have to have in order to make paper. So for example, we have reeds that are being harvested in China in the 1930s. That really terrible looking picture in black and white to the right of it, that is rags, as in literal rag clothing. That's what a lot of paper was made out of in Europe for several hundred years, not centuries. Down here in the bottom left, next to this big mallet, is a mulberry plant called kozo that's used to make a lot of paper in parts of Asia, bamboo, and then the green one here in the middle that kind of looks like a banana plant. It is in the banana family, but it's called abaca. And you'll be hearing a little bit more about abaca later on in the presentation. And then the final picture in the bottom right, those are all sorts of different plant materials that paper has been made out of. You'll notice I left wood out of this. Wood is what we quite frequently make paper with in the Western world. There's a whole additional process that goes into preparing the fiber when you're using wood pulp, but right now we're not quite ready to talk about that. So you've gathered your fibers, and then you have to prepare your fibers. So this is where water starts coming into the process beyond the fact that you needed water in order to have the plants grow. So the first thing is retting, R-E-T-T-I-N-G. You can think of retting as rotting. So in this lower right-hand picture down here, you can see that plant fibers are being deposited into a water-filled, essentially, it's not a swimming pool, but it's a water-filled hole that's been lined so that the water will not escape. And then the fibers are going to rot for about 3 months. So you're going to have to keep adding water to it because of evaporation, but you are breaking down the fibers, you're breaking down the bonds and the fibers, and the water is doing that for you. You're also going to cook your fibers. So you can see bottom left, that's kind of it's not a kiln, but it's basically a giant pressure cooker that would be used to cook your fibers. So you're going to put your fibers in, add in a lye or a caustic material to help break your fibers down, break the bonds between the fibers, and just sort of cook at a low temperature for an extended period of time. As time progresses, processes get more sophisticated, and so upper right-hand corner, you see these big ball-looking things. Those are digesters, which are basically fancier versions of that cooking container you saw in the lower left. And then the other way that water is going to be used in this portion of paper making is with the stamper, and that's what the illustration is showing. So the stamper was powered by a water mill, by a water wheel, And coming off of the bar, and I apologize because I am not an engineer, so all of that technology sometimes just escapes me. But coming from the water wheel, it powers these elements that are called very creatively stampers. They are big blocks of wood. They're about 2 feet by 2 feet, and they have big metal spikes on the bottom. And they go up and down, stamping. Best part of paper making, super obvious answer for everything. So it goes up and down and it shreds your rags apart, getting them closer to being able to be turned into paper. So we still haven't even started making paper yet. Now we're ready to form sheets. What we're seeing here are a whole bunch of different ways that sheet forming happens. The definition of paper making that we use in the Paper Museum is that you're going to have plant material that gets pulped, and then it's formed into a sheet using a screen, and the pulp has been diluted in water. So we have a ratio that we use of about 95% water to 5% pulp. If you are in a commercial mill, so going out to one of the recycling mills that's outside of Atlanta, you're looking at about 99% water to 1% pulp. And I do feel like at this point, I do need to say the paper industry has been working for a long, long time to reduce the amount of water that is necessary to produce paper. And also they are looking into what they're calling no water production, so a blown technique. I'm not convinced if that is still technically paper, but that is way more inside baseball than you all really ever need to know. So fun trivia conversation, right? So there are a couple of main ways that sheets are formed. The gentleman in the top center is doing what's called a Western style. That's where you have your mold and decal. You dip into a container of water and pulp and you bring it up, the water drains out, the pulp stays on top. And then what the people underneath are doing is they are removing that piece of paper from the screen and putting it onto a felt blanket so that they can then do the next steps. So that is a dip method. What's happening here in the lower left is the sort of opposite method. It's called the pour method, P-O-U-R, and that is where you create what's called a decal box. So you have your frame for how big you want the sheet of paper to be, and you're going to put a liner underneath the between the edge of the frame and where the screen is. Then you pour in your pulp and water combination. With this one, you need less water than you would use in the other sheet forming method. And after you have everything the way you want it, it's like that magic trick you've seen where they rip the tablecloth out from under the place setting. Maybe that reference is still valid. So they remove the plastic and then the water drains out and the pulp stays on top. So we actually do this technique at the Paper Museum when we do something called big paper. When we make really large sheets of paper, like 4 foot by 6 foot sheets of paper, we use this method versus the dipping method because we do not have the arm span to reach 4 feet by 6 feet to go into a vat, nor do we have a vat that big. And then the large black and white photo on the side, you're actually seeing several things happening. The gentleman who's standing in a bucket is actually pulping fiber with his feet. So he's walking around in a bucket that's full of water and fiber, and he's breaking them apart. And then the woman in the foreground is forming a sheet of paper. A similar process, it's that dip process where she's dipping in, water is draining out. This one is, I cannot remember where this one is from. She may be doing one of the processes where you're going to dip a couple of times. And that's, again, very specific information that we don't have to follow up with today. All right, so you formed your sheet of paper, and now you have to dry your paper. Get rid of the water. I don't know if you've seen the meme about making pasta. It's you get the dries, you wet the dries, you dry the wets, you wet the dries, right? So that's basically what we're doing here, is we now need to dry the paper. We need to take it from this large percentage of water where it is essentially a liquid and making sure that it becomes a solid material. So drying the paper. You can dry it on the mold, you can dry it on a smooth surface, or like the drawing on screen shows you, is they would actually remove the paper from the molds, press the whole thing, and then hang it up to dry on the equivalent of a clothesline and have these spurs of paper drying all together. So getting rid of the water at this point. Why water is so important in paper making is because of hydrogen bonds. So what makes paper paper is that you have this cellulose material that is held together with hydrogen bonds. To make those bonds happen, we add the water in, and the hydrogen is very happily moving from the cellulose to the water. And then as you're removing the water from your mixture with the pulp, from the slurry, those bonds are going to start forming between the actual cellulose material itself. And that is what's causing your paper to hold together. So you've all probably experienced, the good paper towel versus the bad paper towel, right? The good paper towel, it gets wet and it just, good paper towel is going to hold its strength. Bad paper towel is going to fall apart very, very quickly. There are times that you want to have a high wet strength in your paper. Wet strength is what we call it when you, how wet the paper can be before it starts falling apart. Sometimes you want a really high wet strength paper towels. Sometimes you want a low wet strength toilet paper. So it really depends on what you're doing. There's no such thing as bad paper. You just need to have the right paper for the task you're performing. So you want something that's going to be absorbent, yet still hold together. So for example, tea bags and coffee filters made out of paper, they need to be able to stand up to getting wet for an extended period of time. There are other things that don't need to have that same strength. So just all things that you never thought about when, picking up your to-go order. All right, is it possible to have paper without water? Now, I'm a big proponent of you've got to have that paper mold and you need to have the water and the slurry in order for it to be paper. This is a very, very hot topic in the paper making community. There is also the very valid and equally correct answer that you don't have to mix your fiber in water in order to produce paper. So this is what I'm showing are some historic examples of making something called bark paper or bark cloth. Now we could veer off into another conversation about bark cloth and bark paper and get the textile people involved and just have a regular brawl going on, but we're going to skip that today because everybody wants to claim this particular practice. So what is happening, and you can see, basically the bark, the inner bark of certain trees is harvested. And then using literally sticks, the bark is soaked in water. So you don't need a whole lot of water. It's soaked in water, it's gotten wet, and then it is beaten out into a thin sheet. And so it will just go far broader than you could imagine it could do. And so it gets used in a lot of different ways. There is a very valid argument to say that this is paper. I'm not going to solve that argument today, but it's a good one to have. These are a couple of examples of bark cloth that are in the museum's collection. Bark cloth is used for many, many different reasons. And the communities and cultures that have developed bark cloth over time and bark paper are in places where you say, oh, well, that kind of makes sense. They're in places that don't have a whole lot of potable water. So if your water is a limited resource, you need it for cooking, you need it for growing your crops, you need it for watering people and animals. You're not going to use it for another aspect, right? You need water to live. So over time, these cultures have developed a way to create a flexible, malleable material that can be used for communication, can be used for clothing, can be used for housing materials that does not require a huge amount of water. So theoretically, there is something that the paper industry could take from the bark paper processes. So essentially, they are physically manipulating the fiber into being paper. There is still hydrogen bonding that happens there, so that's a pretty good argument. This piece on the far left, where you can see this really beautiful pattern on it, it feels like a very finely woven piece of cotton that is made out of bark. and it's translucent when the light shines through it. It is absolutely gorgeous and beautiful. You can see that it's from Hawaii, and it's from around 1760. So it's incredibly strong. It's really, really gorgeous. And whether or not it is paper, it is an object that has not only served the task it was designed to do incredibly well, it has also withstood 2 centuries of opportunity for destruction. So it's a really incredible piece to be able to see. The piece in the middle is a spirit figure, and this is something that is produced by the Otomi people in Mexico, and so they are using their bark paper as a means of communication to the spirit world, to sort of inform what's happening here in the terrestrial world. So a lot of these pieces are not meant to be permanent, long-lasting pieces. A lot of times they are actually destroyed after production as part of the ritual for using them. All right, so now we're going to get into water again, because that's what we're here to talk about today. You can see here, this is an illustration of a paper mill, an Italian paper mill, and you can see a whole row of stampers there. And there are still some mills that use stampers. They tend to do the handmade paper at this point. It's not something that people are typically using at this point. And then you can see the vat over on one side. A mill would have had 4, 5, 6, 7 vats going at a time. You can reuse the paper, or sorry, the water that's in the vat for quite an extended period of time, but also you do need to have your mill located on a water source so that you can then grind up your fiber to start, to be able to start that paper making process. This is a picture of the city of Nuremberg. It comes from the Nuremberg Chronicles. And what is significant to the Paper Museum about this image is that in the bottom right-hand corner, that little cluster of buildings, that is Ullman Stromer's mill. That's great. Who's Ullman? Yeah, this one down here in the bottom, the whole little like 4 or 5 down there. So Stromer was the first person to bring paper makers to Germany to make paper. And this is in 1493. I think it was about 1491, maybe slightly earlier, but not much earlier than that. The folks in Nuremberg and in other parts of Germany recognized that, wow, this paper material, it's pretty awesome. The first paper mill that had been built in Europe was in Spain in the early 11th century. And then about 100 years later is when the first Italian paper mill gets built. So we have a center, not center, but the spread of paper making around the Mediterranean, and then it slowly starts moving northward after that. I also like to show this particular image because, yes, it is the first depiction of a mill, and Stromer, he was not making the paper. I feel like that needs to be clarified. He brought in experienced, knowledgeable paper makers, but this is also to show you that labor issues have always been around. So he brought a couple of Italian paper makers with to start this mill, and they come and they start working and they're making paper, and then they discover that the wage they're getting paid is really not a living wage, and they essentially go on strike. They're going to go out, they're going to make their own mill, they're going to be paper makers and get the money that they should actually make. Stromer imprisons them in the mill until they agree to not make paper for anyone and abide by the original terms of the agreement. So, good times. Who knew that there was such scandal
in Germany?
Yeah, well, and in paper making. I mean, if you had to tell someone, oh, I'm going to hear talk about paper today, you probably got a lot of looks of pity from your friends. So here is, again, sort of showing you the full aspects of the mill. You've got the vat there with the paper maker who's pulling the sheet. And then that long sort of trough next to the paper maker is where he would then slide the mold and decal down. And then the couche, who's the gentleman standing in the center. Actually, that's not true. The gentleman over on the far side, right over here, looking like he's laying something down, he's called the coucher. That's a French term. It looks like the word coucher, but it's coucher. And he is putting the paper to bed. So he would pick up the mold, he would remove the paper from the mold onto a felt, put another felt on top of it, and building a stack higher and higher until eventually the whole thing gets pressed in the very cleverly named press. You never saw that one coming. So the press screws down and it presses down, squishing out the water so that you have that hydrogen bonding taking place. And this is the Rittenhouse mill, which is the first mill that was built in what is now the United States. When paper making spread from Europe into North America, the first mill was actually built in what's now Mexico City, and it was in the early to mid 1500s. And there's some really interesting information out there about Mexican paper making and the obstacles that they were having to overcome. But the Rittenhouse mill, if you've been to Philadelphia and you've been to Rittenhouse Square, that is the same family. So the Rittenhouses were the first people to make paper in what is now the United States. The mill still stands, but it is a recreation because it was washed away by a flood. Mid-19th century, thereabouts. So they've done a recreation, but it's pretty cool. This is an example of one of the objects in our collection that is relevant to our discussion of water today. And this is the mill journal of the Summers Paper Mill in Dorchester, Massachusetts. And it is keeping track of the paper that was being made in this mill in 1799. This object was not ever intended to last as long as it did. It's fantastic. It's about the size of the monitor here. It's been sort of stabbed together and it looks like a shoelace is being used to tie it all together. Somebody put a coffee cup on it at some point in the last 200 years. I mean, it's absolutely, they practiced their writing on the front, they doodled, it's great. On the inside, what you can see here is the documentation of the paper that was being made. So you can see across the top that you've got at least 3 people operating vats. It looks like they've got 5 vats that are going. So those are those angled there at the top. Just out of curiosity, can y'all read cursive? Some, yes, no, maybe, okay. And then over on the far right-hand side are notes about the weather. Why on earth do they care about the weather?
And they have to dry the papers.
They've got to dry the papers.
They don't want to rain.
And also the relative humidity of when they're making the papers as well. So there are a lot of additional factors that go into paper making, particularly in an era of no climate control. I mean, whatever was happening outside was probably happening inside the mill as well. Maybe not rain, maybe rain. So it's just a really, really cool example to see what was going on. Like there was a nor'easter going through, or it was cloudy or whatever it was, but the weather had an effect on the quality of the paper. So if you wanted to know why this paper is really good, you'd look and see what day it was made, and then you could see something more about what was happening with the weather. With industrialization, we go from using a lot of materials that are, well, we're still using the same materials, we're just using them in larger quantities and we're adding machines into the mix. Industrialization is also when we make the big change from using things like cotton and linen to using wood pulp. And I don't have a slide on this, but one of the big things with wood pulp is it has something called lignin. And lignin is wrapped around the cellulose. It's what allows trees to be vertical, essentially. That means it's going to prevent hydrogen bonds from happening. So we have to get rid of the lignin in paper making in order to be able to make paper out of trees. So some of the machinery and things that you would have, for example, in the paper mill and wood pulp news, there we go. Very exciting, thrilling articles about new technology in wood chippers and how we're going to be dealing with lignin. And if you have any suggestions on what to do with lignin, the paper industry is very interested because for over 100 years, they're still trying to figure it out. The joke is you can make anything with lignin except money. So this fellow is Nicholas Louis Robert, who was a Frenchman, and he was a mill manager. He got very, very tired of the people who worked in his mill arguing with each other. And he said, well, I'm going to solve this problem by inventing a machine to do all of the work. So this is an example of the Robert paper machine, which has a big vat. It's going to pull the pulp up from underneath, spray it onto this movable web on the top. And so you can make a lot more paper in a shorter period of time. You also only needed 2 people to operate this vat instead of 7 people. So your cost savings go up tremendously. Unfortunately for Robert, he did not have enough funding to be able to continue producing these. So the Foudrinier brothers in England actually got the patent on it, and we refer to that machine as a Foudrinier. Mummies, I am not jumping ahead in our season, but paper has been made out of mummies. And yes, is it a wise choice? Probably not. But there was a period of time in the 1860s because mummies are wrapped in linen. Linen is a really great paper making material. So these mummies, they're just lying there, not doing anything, not using the linen. So to be fair, mummies were being used for a lot of other things during this time period. They were being ground up and used as medicine. They were being used as dyes and paints. Not just human, but also the mummified cats and dogs and things like that. Where this is something that was being used by people in the United States and in parts of Europe as well. So it was kind of it was not a great time to be a mummy is what it boils down to. So why I bring it up with paper making is we know of at least 2 mills that advertise that they made mummy paper. Unfortunately, we have no way of knowing if any of the remaining samples from these mills are actual, made from mummy linen. We can identify that it was made from linen, but we wouldn't be able to identify if it was from Egyptian linen. At least nobody has ventured down that route that I'm aware of. Why it matters is one of the mills that reportedly was doing this was cutting open the mummies and depositing the insides into the nearby river that also powered their mill, which then a cholera outbreak happened the next town down, and it was blamed on the depositing of the mummies into the water, the drinking water system. It's also the manufacturing system, water and all the water. Again, this is mid-19th century. We don't have OSHA. We don't have any laws to protect us from anything coming from upstream. I mean, it could have also been the raw sewage coming from the mill that caused the cholera epidemic. We'll never know, but mummies is a fun one to bring out there as well. All right, not mummies. This is the Institute of Paper Science and Technology, which is where the museum is housed. Actually, we're housed in the Renewable Bioproducts Institute, but it used to be the Institute of Paper Science and Technology. And these are just a few of the things, lower water usage per unit of production, that the IPST and RBI have been researching and studying over the last almost 100 years. So there's a lot that gets done in various different aspects. I think I've got one more. Oh, standards and testing. That's my personal favorite. Those little round circles on the bottom of cardboard boxes that talk about the edge crush test. That was developed by the Institute. It's very exciting. All right, this is us, the Paper Museum. And we were founded not by Robert C. Williams, but by a man named Dard Hunter. And that's him in this nice portrait in his library. And then he's standing next to the president of the Institute of Paper Chemistry, showing him how a Pressworks. Dart is also known for being a paper historian. And so he wrote over 20 books in his lifetime, 8 of which are completely handmade. But we're talking about water today. So I wanted to show you an installation piece that we had at the museum in 2015, made by the artist Lee Emma Running. And it consists of muslin, cochineal, and abaca. And this is a detail of it. And I've got about a 3-minute or video of this piece being made. It well, you can see how big it is. It took 5 days to install. That is specially formed sheets of abaca paper. So you'll be able to see some better examples. And it's still wet as it's going on. See what happens when it dries. Initial plan was to cover the entire area that was dyed with the abaca. But eventually we changed, well, Lee changed it after what she got into the process. If you notice up at the very top, the color is changing from that red into. So that was the making process. That was a lot to see, but we're not going to watch it again. If you want to watch it again, it's on our YouTube channel. All right, so this is what it looked like when it was all finished. So you can see that it has shrunk, it has pulled, it has gathered. There seems to be some color gradation happening. How did it get to be like this? So breaking it down to begin with, upper left, those are the insects that create cochineal. Have you heard of cochineal before? Right, so cochineal is a red dye. You can see there's the red dye right next to it. The cochineal comes from the exoskeletons of these insects. So you need a whole bunch of them to be able to produce any quantity of red dye. So it was very expensive, hard to make color historically. The other really cool thing about cochineal dye is it is a natural pH indicator. So depending on what you mix it with, you can take it from being that neutral red to being an orange for an acid or a purple for a base. Hold on to that information. So what Lee did is she took 25 yards of linen cloth of muslin and partially dyed it with the cochineal. So that's what's happening down here, big container of dye, and it's getting to titrate up into the threads of the piece. She brought these pieces to Atlanta, and then we installed them on the wall in our gallery. We put a piece of plastic behind it so that we didn't completely destroy the drywall. And then she adhered these sheets to the top. She did not apply a mordant to this dye. A mordant is what fixes your dye. So at this point, if these sheets got wet, they would start bleeding. They'd start running because that dye is not being held in place on those fibers. So that was the initial setup. Now we get into production. So you saw in the video, there were a lot of people around. Lee was the only one putting things onto the wall. There was a whole crew of us in our classroom getting these abaca sheets ready. So the fiber that we used was abaca, which is from the banana family. And the really cool aspect of abaca is that the longer you beat it, the more you prepare it, the more it shrinks when it dries. So cotton, for example, doesn't really shrink. We beat this abaca for, I believe, 8 hours, which is a long time. Normally it's about a 2-hour beat for abaca. 8 hours, 12 hours, you're getting really, really long, and it's going to shrink a lot more. So at the far end, that was our vat. So we had water and pulp, and we were probably more at like 85% water to 15% pulp for this. We wanted really thick sheets of paper. So we pulled the sheet of paper, and then we had all of these bars set up because the pulp drained really, really slowly. It took about 15 minutes for enough water to drain out for us to be able to pick it up and not have it just slide off of the mold. Then the person here at the closest to me with the black vat in front of her, she's got a plexi tray in front of her, and she has interfacing, which is what's used in sewing, and it's very thin and flexible, and it's a non-woven, and the pulp is not going to stick to it. So she's laid down a piece of interfacing on that plexi and then couches the paper. That means she's taking the paper off of the mold and putting it onto that interfacing. And you can see hanging over the edge, those are stencils that we used. So then she puts a stencil on top of the paper. And then you can see me down here using a hose. We do what's called a blowout. And that means turn on the hose and we blow out all of the fiber that is not covered up by the stencil. This way we get this very lacy piece of paper as a result. So it's very wet. It's not really paper at this point, basically. And then we remove the stencil, let it dry a little bit longer, and then it goes into the gallery to be hung up. So these are some close-ups, some details of what the piece actually looked like. And Lee was inspired by aerial views of riverbeds and deltas, and also looking at leaf veining. So you can see both of those in that stencil. So she would line the stencils up when she was putting the pieces together. She'd actually cut them so that you'd have like a vein coming off, and then she could have another one that lined up next to it so that it would just flow easily. Up right here, you can see the section on the left, that is a freshly applied abaca paper. To the right is one that's been on for a little bit longer, and it has started absorbing some of the color. She was wanting to have the color, the dye being pulled into the abaca and dyeing that more. Remember that whole pH indicator thing I mentioned earlier? You'll notice down here, we got a lot of purple. The tap water in our classroom is a little basic. We found that out as we were couching things onto the wall. So that was exciting. And then we would also get, and you can't see it really great, but as the water is coming out of the pulp and coming out, well, basically out of the pulp, it would run down the fabric and you would get these trails of dye through the sheets. And you can see where it's stretching. We didn't want to cover the fabric entirely. We wanted to have places where there was no fiber because we wanted to show that tension of what's happening as the fiber is drying. It's pulling everything up. So, and oh, by the way, we have galleries. We are, as I mentioned, we're open Monday through Friday from 9 until 5. We've got lots of things to see, and we are actually having an exhibit reception on Wednesday, October 2nd from 4 to 7 p.m. Everyone is invited to attend. It's for our new exhibit, which is called Build It, and that is a cardboard construction exhibit. So if you are needing some time to decompress and maybe turn off the computer for a while, come to the museum because we have cardboard and tools and tape, and you can build to your heart's desire and then leave it for us or take it home with you. We don't care. Leave the tools, take the card. So just a couple more slides. Oh, one other thing about water. Water isn't always our friend. We did have a massive flood in 2022. And so this is where you don't want to see water. 3 inches of water in collection storage. And when you're a paper museum, it's not a good time. So we've got some water there. We have to get it all taken out. That's our new beautiful water-free space. And then other things that we're going to be doing with water, making paper, doing artwork that is paper, that is water-based. This down here on the bottom left is suminagashi, which means ink floating on water. It's a very, very cool activity to do. And that is who we are. You can find us on Instagram. You can find us on Facebook. You can also find us on campus.
Thank you. Any questions from the, I wonder if there is someone on the, let's see if you click on the, at the bottom. There is another person. Who is the set? Can you click on the participant down there? Is Elizabeth?
Said it was Lizzie Storm.
Elizabeth iPhone. Elizabeth, do you have any questions? Maybe she asked a question on the chat. Let's see. Ah, she is Lizzie Storm. She gave a talk last week. She's a professor, an artist at Georgia State.
Fantastic, excellent.
So she has a question.
Lizzie, go ahead and ask it. You can type it in and I'll read it out and do my best to answer. Saw some women in the photos I shared. Do I know if women, oh, that's a good question. Did women work in the early paper making industry? And like any good historic question, the answer is it depends. So it depends on where in the world and it depends on what task we're talking about. So in parts of Asia, many times the women who were forming sheets, you might have in like Indonesia or in other parts of Southeast Asia. I can tell you that almost exclusively the people who are making bark paper and bark cloth are women. In Japan, it was mostly men who were making the paper because, but the women would help prepare the fiber. So there was a task that was called cherry picking, which is when you're going through the fiber and you pick out any discolored pieces that you don't want to have in the paper. So that was one of the tasks that women did. But there was a song that was written, it was something like, girls don't grow up to marry a paper maker. He works all the time and he has no money and it's a horrible job. So you marry anybody else is basically. It's a better song than that. I'm not a songwriter, but there was definitely there. And then in in European and North American papermaking traditions, the women were not often forming the sheets of paper because the molds were so big and so heavy. That was usually something men were doing because of the wingspan, essentially, that was needed for the size of molds that they were operating. But women were preparing the fibers, and then women were also used to inspect the sheets that they came inspect the paper after it was produced and dried, they were doing the grading of it. So this is a top tier, this is a medium tier, this is a bottom tier. Women were the ones who were doing that aspect of it. So they were doing skilled tasks, but not necessarily that one component of the physically pulling the sheet. Today, if you're looking at who's making paper, it is mostly women. So, Lizzie, I hope that gave you a little bit more insight. I'm waiting for somebody to do a social commentary on, paper making societies and things like that. It will not be me, but I will happily read it. You said you had some questions?
Yeah, so I know right now, because I didn't know you can make paper from like clothes and stuff. And I know right now, like fast fashion and everything is like super bad for the environment. And they're like throwing tons of clothes away and like burning them.
Right.
So would like making paper from that be like feasible, or is there like too much chemicals and fake
So
stuff in
you
it?
really need to have a cellulose-based, you need to have something where that hydrogen bonding can happen. So a lot of the problems with the fast fashion is you've got like a cotton poly blend. So the polyester is a huge issue. So we have actually like made paper out of t-shirts before. As long as they're 100% cotton, it works fine. One of the things you have to do is you actually have to like cut all of the stitching, because that is a polyester thread. And it'll mess up your machines and it doesn't bond. Blue jean paper is really nice. You do run into the same issue with denim as well. There's a lot of polyester that goes into denim now. But I don't think it's an unsolvable problem, or not a problem. It's not an unsolvable challenge. The repurposing and the reusing of things. If there was a way that you could, get it to bond a little bit more, you might have to add some sort of, which then develops a whole other issue, right? Like, okay, we're trying to take this material and reutilize it in a different way, but to make that happen, we have to add something new to it that may have other unintended consequences, but you have to pick which consequences you want. So, that's a great question. And there are definitely places that are looking into that and how to adapt. That is one of the really great things about paper is it is really easy to recycle. We, as a society, have done an excellent job getting that message out. Hey, this is a recyclable material. And usually paper can be recycled like 3 or 4 times. What happens is every time it gets recycled, the fibers get shorter and eventually they get too short to bond together. So every time you recycle paper, it goes down in quality. And that's not a bad thing because, we don't need, oh, here's my resume paper, here's my final thesis paper, my birthday card paper. Like sometimes I just need a box, right? So eventually it becomes box material. Or that wavy bit in between the corrugation. A lot of times that's actually made out of like straw and things like that. It doesn't have to be super strong. So, and that's an agricultural waste that'll get reused. So,
Any other questions? Okay, let's thank our speaker, Regina. Thank you very much.
Those there.